Hi and welcome back to my channel. So in the last video we talked about derivatives, including how to include limits to find derivative of a function at a point. So in this video we are not going to talk about limits. We are not going to use limits to find the derivatives. Rather than we are going to look into the algebra of derivatives itself and see how we can find the derivative of different kind of functions. So I'm going to write some rules about the algebra of derivatives which are going to be applied to solve problems. So the first rule we have of derivative is that this is the notation d by dx. So if I have to find the derivative of addition of two functions f of x and g of x, let's say, so this is equal to the derivative of f of x plus derivative of g of x. Now the second rule we have here is derivative of f of x minus g of x equals the individual derivatives minus derivative of g of x. So please note these down. And the third one, we have derivative of a product of two functions f dot g of x is equal to the differential derivative of f of x times g of x plus derivative of g of x times f of x. So this is also known as the product rule. If let's say I denote this as u and this as v, then we can simply write that d by dx of u times v, these are two functions, sorry, I forgot to mention that these two functions, the f of x and g of x, they have the same domain. So x is same for both of these two functions. So derivative of u dot v is equal to u dash v plus v dash u. So by dash I am denoting as a derivative. So this is also known as the product rule. Similarly, if we have two functions and we have to find the derivative of, let's say, u by v, this is equal to u dash v minus v dash u by v square. So this is also known as the quotient rule. So now we are going to solve some problems using those rules. Now let's say I have a function f of x and equals x. I need to find the derivative at x equals a, right? So previously we used to use limits to find the derivatives. Let's go back and let's see how we used to do that. So we had f dash x as limit h approaches 0 f of a plus h minus f of a by h. So using the previous formula, we had f of a plus h will be a plus h minus a by h. So limit h approaches 0. So this and this will get cancelled and we are left with 1. So this is a little bit tedious, it has a lot of steps, but using the new rule we can, let's say using the product rule, because function of x equals x, we can also write it as x times 1, right? So let's say this is u and this is v. So we can find the derivative of u dot v as u dash v plus v dash u. So which gives us the derivative. Let's start with u first. The derivative of x is 1, the derivative, and then we have times v, that is 0.1 dot 1, then plus derivative of 1 is 0 times u. So this gives us 1. So the reason that I've written 0 here is this part is 0 because whenever the derivative of a constant function is always 0. So I'm going to write this down. Derivative of a constant function or number is 0 because it is not changing with respect to x. There is no change in the function with respect to change in the independent variable. So in this case we have x. So that's why when we have function, let's say we had function of 1, right? We had just 1 here. So it is a constant function and function of x has 1. So if we derivate it, differentiate it, it is going to be 0. F dash x is equal to 0. So that's why in this question we have derivative of x times 1 equal 1. Now let's move on to the second question we are given. Let's find the derivative of a function f of x equals x raised to power n. So when we have a function like this, there is a rule which says that the derivative of this type of function will be equal to, let's say, dy dx of x raised to power n will be equal to n times x raised to power n minus 1, and n can be any real number. N can be any real number. So if we solve a question based on this, let's find the derivative of function of x equals x raised to power 5. So the derivative using the above rule will be equal to d by dx of x raised to power 5 will be equal to 5 times x raised to power 4. So we have a new function of x equals x plus 1 by x. So here we can see we have a numerator and denominator, so we can use the quotient rule here, right? Using the quotient rule, So we know that d by dx of u by v equals u dash v minus v dash u by v square. So in this case we have a derivative of x plus 1 as 1 times x and then minus v dash, that means derivative of x is 1 times u, that is x plus 1 whole divided by v square, that is x square. So this gives us x minus x minus 1 by x square. So ultimately you are left with minus 1 by x square. So this is the derivative of f of x. So in today's video we talked about the algebra of derivatives without using the limit part. So similarly in the next video I'm going to talk about more about derivatives, and I'll also share the link in the description about previous videos on derivatives, so please do check them out as well. Thank you for watching.